In this series of lectures, we're going to focus on bonding. And we'll introduce three types of bonding, talk a bit about one, and then focus most of our time on covalent bonding. Our goal is to understand how the atoms of THC are able to connect together to create a unique shape and order of connection that defines the molecule. Because it's that shape that's going to determine how the molecule interacts with our body and system, and also how it behaves in a plant, and how we can extract and isolate it out of a plant. So let's start with some basic definitions of different types of bonding. We've got three main categories: ionic bonding, covalent bonding, and metallic bonding. So ionic bonds are, and this is kind of like a big pile of words, electrostatic attraction between anion and cation. That just means it is an attraction between opposite charges. So there's a fundamental law of nature, but that we focus on in chemistry, called Coulomb's law, that describes the force of attraction between opposite charges, or the force of repulsion between like charges. And so if we have something that is a negatively charged anion, like chlorine, chloride, it would be attracted to a positively charged anion, which we call, or positively charged ion, which we call a cation. An example of this could be sodium cations. And that attraction between those two charged particles creates the ionic bond. A lot of textbooks say it's the transfer of the electron from like the sodium to the chlorine. And this is like a minor detail, because a lot of textbooks like to say that. I disagree, but it's that transfer of the electron that occurs is really a chemical reaction. And when we think about the bond itself between ions, it's assuming we already have ions, in that their attraction is really just about those opposite charges. And that's a pretty strong force. We typically see it between a metal and a non-metal. And like everything we'll talk about in this class, there are exceptions. But it's typically, if you see a metal written first in a chemical formula followed by a non-metal, you can assume you're looking at an ionic compound. These are also typically called salts, even though in our like in English, like common language, when we say salt, like please pass me the salt, we're really talking about table salt or sodium chloride. Sometimes they put some potassium chloride in it too, to be low sodium salt. But a salt is really just anything that is a metal cation paired with a non-metal anion. So it can be lots of things. Magnesium chloride, it's salt. And lots of the ingredients, if you look on like the back of anything that you're eating, you might see things like magnesium sulfate or magnesium chloride. These are other salts that are different from sodium chloride, and so they don't have that same magical taste, but are still ionic compounds. All right, so those are ionic bonds. And then we also have covalent bonds. These are between two atoms that are going to share electrons. And the bond itself is sharing electrons, or sharing the attraction of electrons, typically two, to the two nuclei that are positively charged on each of the atoms. So this usually occurs between two nonmetals, or a metalloid and a nonmetal. And we'll go into this type of bonding in detail, but I have an example of hydrogen fluorine here. You can kind of imagine my hydrogen and my fluorine would probably each contribute one electron that they're sharing together. And this circle I'm drawing is just representing the cloud, or the space that these two electrons would be shared within. And then fluorine also has these other electrons that aren't actually participating in that bond, but the bond is just the ones that are being shared between the two. And we'll dive into that more here in a second. Now, metallic bonds, we're not going to talk about very much. because we're focusing more on the organic chemistry that we find in cannabinoid compounds of the cannabis plant. But metallic bonds, just to kind of complete our trio, they really are atoms that are evenly kind of they're stacked up in an order, and you really get this picture where it's nuclei that are evenly distributed in a space, and the electrons around them kind of just like bleed into each other. And so the electrons kind of become like a sea of electrons that are distributed amongst the space occupied by the nuclei that are being distributed apart from one another. It's often thought of as like a sea of electrons. Um, yeah, and so this happens only with metal atoms, and it could be all the same atom and be an element, or it could be multiple different types of atoms, and then you'd have like a metal alloy be an example. But yeah, so it's going to be just like these nuclei centers, and then you've got these electrons just kind of everywhere, and lots of them. So you can kind of think of it all as one kind of distributed electron cloud. And so these are our three types. We're definitely going to focus here on covalent bonding because it describes a lot of what's going on in organic chemistry, which is going to be kind of our focus here as we start thinking about how we can isolate and separate certain specific compounds. Still, we run into ionic bonding a bit. So we'll have a brief lecture that kind of covers ionic bonding in a little bit more detail, and then we'll shift our focus into covalent bonding.